Good day everyone, this is Engineer EMV and welcome to my channel. Before we proceed, hit the like button and subscribe for more civil engineering topics and practice problems in my channel. In this video, we are going to talk about area under the curves using integral calculus. In solving the areas under the curve, we have 4 basic steps to make solving easier. The first one is to graph the curve or the line. Graphing the curve or the line lets us analyze easier the problem. It is not necessary to plot every point on the Cartesian plane. We only need to see the trend of the curve or the line to see where it is going in the curve. Number 3, analyze the strip. In solving areas under the curves, we can use vertical stripping or horizontal stripping, depends on the problem. And lastly, we need to integrate our differential strips to sum up the total area between the curves. Before we proceed, we need to follow a rule. The endpoints of our differential strip should not lie on the same curve or on the same line. Its two endpoints should be on a different curve or a different line. Let us now proceed on how we are going to use the vertical strip. Take note that this differential strip is a very small strip, and being very small, it is considered to be a small rectangular strip. As you can see, the differential strip represents the area of the curve. So we isolate our differential strip. And after isolating it, we are now going to focus in solving the differential strip. Since this is rectangular in shape, the strip should have the following dimensions. By looking at our curve, we follow the rule that the endpoints of the strip should be on different curves. Since we are using vertical strip, we are going to run our differential strip along the x-axis. So for the width of our rectangular strip, we can set it as dx or differential x, since this will be our varying value. So for the length, it can be represented as y. Now, our rectangular strip has its own dimensions. It has y for the length and dx for the width. So by recalling our area for the rectangle, it is length times width. So in our case, the differential strip is equal to y dx. So to solve for our area, we should integrate our differential area. So area is equal to the integral of y dx. Take note that we measure the values of y from the positive x-axis. So by looking at our curve, this will be our YO or our Y outer, and this is our Y inner. Now we can get the value of Y by subtracting the values of Y outer minus Y inner. So Y is equal to Y outer minus Y inner. And to finalize our equation, we substitute our values. The area is equal to the integral of the quantity y outer minus y inner dx from a to b as our limits. And this is how we use vertical strip. In using horizontal strip, we can simply follow the principle in using vertical strip. So in this case, I will draw the horizontal strip in this curve. We have two different curves, and our rule is followed that the endpoints of the curve should not be on the same curve. So since we are dealing with the horizontal strip, we will let our strip run along the positive y-axis. So we should isolate our strip and let us name its dimensions. So this will be dy. Since we are dealing with the horizontal strip, we will let our strip run along the positive y-axis. And let us name the length of the strip as x. So similar to our vertical strip, the x values are measured from the positive y-axis. So we can name this as xo or x outer, and this will be x inner. So by subtracting the values of x outer and x inner, we can get the value of x. So let us write it down. The differential area is equal to x dy. So to solve for the whole area, we integrate the differential area. So integral of x dy. Our area is equal to the integral of x dy, in which the x is equal to x outer minus x inner. So now the area will be x outer minus x inner dy from A to be as the limits, and that is how we solve using horizontal strip. For the practice problems, you can refer to the next videos that will be uploaded. That's all for this video. I hope you've learned something, and if you have questions, inquiries, and topics in mind, just comment it down below, and let's see what will be our next topic in our next videos. Don't forget to hit the like button and subscribe for more civil engineering topics and practice problems by Engineer EMV.